Like, what does AI agent mean to you? Any of you? Like in simple words, what is an agent?
Just a functionality which allows directly without interacting any code, directly agent which can access to the API.
Okay, and any others? Like you would have heard of agents, right? AI agents. Okay, so we'll get into that, like what exactly they mean. But see, agents are not anything new. Like agents, what agents mean at all. But what changed now is with the emergence of LLMs, the capability of an agent is completely different now. In fact, when OpenAI started, like in 2015-16, the initial work they did was mostly on agents. They were trying to build different gaming agents, and basically agents are like they're goal oriented. You give them some work and they have to get it done using like their own understanding of the problem, and they get it done. So when OpenAI started, they started working on it and they did a lot of work. But at that time, technology was not sufficient to build real agents because these agents are not able to understand even general use cases. Let's say if an agent has to do some routine work where it goes to a website and books a ticket. And if you just give it a URL and if you ask the agent to look at the website and do that work, that was not possible at that time. Because it needed that real world understanding of what a website is, what that button text is, all that information was not there. So then they tried it using reinforcement learning, where it's like more of a raw approach where the agents used to click everywhere on the site and it used to learn on itself. That was the way, and but then they pivoted mainly to the foundational models. So in fact, a lot of work was happening even outside OpenAI. Like you hear AlphaGo, which was completely an agent which learned itself to play the game of Go, which is considered probably the most complex game anyone can play. And the agent learned on its own, and it was able to beat the professional players in that game. So yeah, like agents were happening, but there was something missing in that at that time. But again, after the chat GPT movement, everything has picked up in agents. That is because now LLMs can give that reasoning capability to the agents, right? So yeah. And really, are they really improving the capabilities of a LLM? If you ask that question, you can see that this is I've taken it from Andrew Ng's team's research report. So this is for coding benchmark. So on the dataset called HumanEval, which is released by OpenAI. So this is for this is like different benchmarks on coding performance using different models. So when they used GPT 3.5, the accuracy was around 48%, and GPT 4 it is 67%. This is just using LLMs. But once you start using agent frameworks to it, using the right agent frameworks, you can see that even with GPT 3.5, it was able to go up to 95%. Right? So, in fact, people say that a lot of investments are going in the foundational model side, but working on the agent probably can improve things much quickly as well, going with the right architectures. So there is no doubt that agents are definitely improving things, and a lot is happening here. So yeah. Yeah, so now let's come to what actually an agent is, right? What makes an agent? So there are a couple of things which are important for an agent. One is reflection. So reflection is these LLM models, when you tell them a work, they reflect on the output and work on that. They just see, it's like when you give a work to, for example, if you have to write a essay, it never happens that you just sit on your laptop and type the entire essay without pressing the backspace. Like you write something, you look back at it and change the thing, and it will be an iterative process, right? But what we see with LLMs is you just ask and it puts everything at once. So that is how LLMs behave. But once you add these things, like reflection is one thing which is an important thing for agents, which really improves the results. And then similarly, the second most important thing is tool use, right? LLMs are like just knowledge banks, probably not even the real knowledge, like the latest knowledge. They're just trained on something. These are just weights and biases which are there, and that's all. Unless they are enabled by tools, let's say if your job is to book a ticket, the LLM doesn't not only understand what is booking a ticket, but it also has to have the APIs to book a ticket, right? So that API becomes the tool there. So agents, one difference between like LLMs and agents is that they also use tools, right? And then planning, right? So again, so planning means if you ask a question to it, it has to like plan what are the steps into it. So these are the main patterns that are seen in current agent structures. But these are all, we are all talking about single agents. But another thing that is also important is putting these agents together, which is also a very popular pattern where putting these multi-agents together and let them collaborate and build applications on that. So yeah, and even in agents, there are like whatever we discussed using tools, planning and reflection, that we have they have put it into different frameworks. These are some standard frameworks that if you look at the literature, you will see that, and there is some good out-of-the-box support for all these frameworks. Let's say if you're using LangChain, this React framework comes out of the box. You can just say, I want to use React framework, and you can use that. So, here I've just listed three different types of frameworks. One is chain of thought, and second is React, and third is race framework. So, in chain of thought, it's the most simplest thing where you give a problem to it, and it just puts it into different steps. For example, if I ask it to calculate something, let's say the question was there are 23 apples, 20 apples are used, and now we bought 6 more. How many apples are there? So this is the response from GPT-4 when I tried yesterday. So you can see that it's doing in a proper step-by-step. That is called chain of thought approach. In fact, you would have seen that initially when GPT 3.5 was released, it used to fail really badly on maths use cases. But they have used, like GPT-4 is definitely an advancement, but they have also added this agentic flows to it, where it actually goes through each step it does and understands that and gives the result. So that is the simplest form of an agent, that is chain of thought. But the problem there is for each of the step, it doesn't really look at the output. It does that step and it moves to the next step. So a little advancement over that is the React framework, where it comes up with a thought, it uses some tools and it acts on it, and it observes the result, and then it takes the next step. So that is a little fine-tuned or better version of the chain of thought. And like they tried it on some data sets like Hotpot QA, where chain of thought was hallucinating 14% of the time, but with this React framework, it was hallucinating 6% of the time. So, a little more, but the problem here, what happens is, it comes up with a thought, it does an action, it observes the output, and it comes up again, it goes into this loop, but since it doesn't have any external thing that is coming, what happens is a lot of times it just gets into that loop only because there is no external data to say that this is not the right path you are taking, right? So the problem with this framework is getting stuck in that loop. Even if it is in the wrong direction, it will just get in that loop itself. So a little advanced version to that is called race framework, which is like probably even if we use race framework, most of our problems we can solve. Like there are even more number of patterns, but this is sufficient kind of. Wherein it also has access to memory. Like you can see that in race framework it has LLMs, which is again common to all the other things. It has tool pool, which is again common to all other things. But working memory and example pools are two additional things that you can see in the race framework. Right? So the working memory is every time it does something, it keeps a track that I have done this thing. And this was the result. So next time if it sees the result not in the right way, it will not try this approach. And even in memory, it has two types of memory, short-term memory and long-term memory. Short-term is like what is happening, but long-term is it can also have access to databases or it can have access to the example pools. What happens is whenever it is working, if it gets the right answer, it stores that into the example pool. So next time it comes across a similar problem, it will use those example pools as well. So this is an advanced thing. So I think whatever we are discussing, these are readily available in frameworks like AutoGen or Llama or LangChain. So you can just use these names and do a quick POCs. It's very easy to do that. And in fact, there is a course on the landing AI, the deeplearning.ai by Andrew Ng, related to agents. I think if you can do that, you'll get pretty good understanding of how to use these things. I didn't include any coding part into it because the time is also very short. But I think I felt probably understanding these things is more important. Once you have that, you can easily do that coding. Because these are all out of the box library methods. Yeah, and in the third, the last one, putting these single agents into combining them and multi-agent architectures. So, like Sonu was talking, what we saw that Devin AI, which was that software, the world's first AI software programmer, they were also using this multi-agent architecture, wherein you give a task to it that, let's say, develop a Gomoku game, and there are multiple agents working together on that. Like there will be a designing agent, there will be coding agent, there will be testing agent, there will be documentation. So all of these things will be working together to establish that or complete that goal, right? So again, like even if you look at this autopilot, Tesla's autopilot and all, they are all multi-agent problems. So and again, there are like two ends of there are two types of architectures there. One is vertical multi-agent architecture and horizontal architecture. Wherein in vertical architecture, it's like a chain of command. The first agent says something and every agent has to follow that. It's like instruction based. But in horizontal architecture, it's more of a collaborative approach. All of them will be talking and they'll be finding what is the right way to do, and then they take a decision and then they work on that. Again, there are a lot of opinions on like which framework is the right way. Is it the horizontal architecture or the vertical architecture? But it again depends on the use case. Let's say if the use case is very clear, then probably vertical architecture helps. You don't have to discuss much. But if the use case is complex, you generally go for horizontal. Again, the problem with horizontal architecture is sometimes they discuss, like these agents talk to each other so much that there will be a lot of noise and it will not go anywhere. It's like very similar to how teams work. Individually, like if you have a very clear thing on your task, you better do it alone. If there is complexity and if you have to figure out things, you probably go with that horizontal approach. So that's on the multi-agent architecture. And then yeah, how do we use it at Cognida, these things, right? So again, based on these things, using these agents and multi-agent architectures, we have these products and we call them accelerators. What you see on the left is predict, lens, synth, and assist. Right? These are like, you can think of them as multi-agent workflows. And we have used different tools and agents to build these things. Right? And for example, you have a searcher agent, image to text converter, database connectors, check data extraction, document classification. All those things are tools. And we use different tools of them, different agents of them and put together to create these workflows, and we have given them different names. Like, let's say if it's completely related to structured data, we call it Predict. And if it is related to images and object detection, anything visual, we call it Lens. And we have something called Synth, which is to generate new data sets. And we have Assist, which is more of a chatbot kind of a thing. So again, it's like we have used, like you can clearly understand that you can see that there are tools which are like very specific tasks it's doing, all of those tools. And also there are agents. So probably one way to differentiate what an agent is and what a tool is if it has an LLM power. If it is LLM powered, you can call it agent because it has the reasoning, reflection, all these capabilities. If it doesn't have that, you call it a tool, right? So yeah, that is the Cognida.ai stack, and probably I can quickly demo you the last one, Assist, and we can see what tools and agents we have used in that. Yeah, this is one application we have built for one of our client, which is again using all these tools and agents. And let's try that first. So it's like very specific to their company's requirement. I'll show you an example with the first style called research, which basically generates a research report given some context. Let's say you want to research on AI agents in education sector. You give all those fields and it comes up with that entire research paper. So to make that happen, it uses all these tools and agents in the process. So yeah. So in the interest of time, I have already filled those things there in the boxes. And if I say generate brief, you can see what is happening under the hood. So it is doing yeah. So as soon as we say generate brief, what it does is it has taken that entire context and it has given to a searcher agent, which takes the text and it does a Google search using that text, and it will figure out what are the right keywords to use for this search. So all that is happening using the searcher agent first. And then that gives the control to the scraper. So it comes up with all the websites and it chooses which websites are the right websites. And then it gives to the searcher tool, whose only job is to just go into all of those websites and scrape the content from there. And then it gives it back to the summarizer agent. So there will be a lot of pages, probably like just for this request, it would have gone through 30 different websites. So from all that, it has collected the information, and the summarizer agent summarizes it and gives it to the editor agent. Right? That editor agent looks really properly at the generated document. It removes if there is any like hallucinations or probably like checking it for the correctness of the report. All that is just like how an editor does in real world. So that editor agent will work on that, and then finally we give it to a report generating tool. So that puts it into a proper PDF format and gives that. So all those things are happening in this use case. And you can see it has generated, yeah, document like this. Yeah. So it's saying what are the possibilities of using AI agents in the tech space. And it is also giving future scenarios of like what AI agents will be in future. And it has also given the references at the end, what all it used. So with this use case, you can see the interplay of all these agents working together. So yeah, that's what we call it as Cognida stack, where we put all these things as tools and agents, and based on the customer requirement, we put them together and we build the solutions. Right. So any questions? Yeah.
Looking at your standing, so it's not really basically structured data and pretty coming. So how do you deal with unstructured data? You have sort of
Sorry, I couldn't.
So I was asking, how do you deal with unstructured data? Because the proof is something basically deals with structured data.
Right.
So how do you deal with unstructured data?
Yeah, when you're saying unstructured, do you mean like images and text?
Unstructured is something like, they do not have any sort of labels and things like that.
Right. Yeah, so see, there are different ways to interpret structured and unstructured. One way to look at it is all these tabular things and all, we call it structured. That is one, and which is not in that numbers format or structured format. Things like images and text, we call it unstructured. So in case of unstructured, we have accelerators like Lens, which is on images, on videos and all. And similarly for text-related things, we use this Zuno Assist platform. The predict is mainly for the structured data only. Okay, then we're good. Thanks everyone.